In this video we solve the vector quantities. If we solve the vector quantities, we can find three parameters: rectangular component of the vectors, direction or angle of the vectors, and resultant of the vectors. If we see the diagram, if we see this diagram, so we conclude that the force is acting on a body with the angle theta. So force divided into or split into two components, that is Fy because it is along the y-axis, and Fx which is along to x-axis. So this is the small introduction of this is a short introduction of this diagram. Now we see how we solve this diagram. If we see this theta, the side in front of theta is our perpendicular. The side in front of 90 hypotenuse, and the remaining value is our base. Now if we see that, we know that cos we know that cos theta is equal to base upon hypotenuse. Cos theta is equal to base is over fx and hypotenuse is f. Divide this side, multiply. So fx become f cos theta. If we further see that sin theta is equal to perpendicular upon hypotenuse, sin theta is equal to perpendicular is over fy and hypotenuse over f. This value divide here is equal to multiply f sin theta fy, or fy is equal to f sin theta. So we can say that if force is applied on a body with the angle theta, so its component divided into two components, fx and fy, called rectangular component, and fx component is derived by formula f cos theta, and force y component is derived by the formula f sin theta. So this is our rectangular components. This is our rectangular component. This is our rectangular components. Now we derive resultant, and now we derive the direction and or maybe angle. So okay, this is our equation 1. This is called equation 1, and this is our equation 2. If we divide equation 1 and equation 2, dividing equation 1 and equation 2. If we divide equation 1 and equation 2, so left side divided by left side, and right side, its right side is written in front of its left side, equal to sin theta, and fx f cos theta, So cancel f and f, fy upon fx, and sin theta upon cos theta is our new trigonometric ratio called tan theta. If we take tan theta in above the is equal to, so we see that theta is equal to tan inverse of fy upon fx. So if we know if we have to find the angle of the force, if the force is applied on a body with an angle, so we use this equation to find the angle of the vector. Now the third third parameter is our resultant. Now we see that how we calculate the resultant. This is our equation 1 and this is our equation 2. If we add, if we squaring on equation 1 and equation 2 and then add squaring, on equation 1 and equation 2, then add. Now squaring on equation 1 and equation 2 and then add. If we square on this equation, it will become fx square f square cos square theta, and then the if we square on equation 2, it will become fy square f square sin square theta. Now adding both these equations, we get left side add into left side fx square fy square, and right side added into right side f square sin square theta f square cos square theta. So fx square fy square is equal to, if we take common from here f square, so it will become sin square theta plus cos square theta. So sin square theta plus cos square theta is equal to 1. So it will become fx square fy square is equal to f square, put 1 here, so this will become f square fx square plus fy square. If we take root on both sides, it will become f is equal to under the root fx square fy square. So if we required in numerical problem that we have to find the resultant of the any vector quantity, so we use this formula under the root x component square plus y component square. Thank you.